Hello students. So we are solving SC chapter 32 electric current in conductors questions, and student, you can find out link of solution of all questions of this chapter below in description box. Student, we have also solved questions of NCERT class 12 chapter 3 current electricity, so you can also find link of solution of all those NCERT questions here in below in description box. So please, if any student is new on this channel, subscribe my channel and let us start our today's class. Student, this question number 26, this is saying, suppose you have three resistors of 20 ohm, 50 ohm and 100 ohm. What minimum and maximum resistances can you obtain from these resistors? Okay, student, we know that for getting maximum value of resistance, we always connect resistances in series, and for getting minimum value of resistance, means minimum equivalent resistance, we connect these resistances in parallel. Okay, so for maximum, what we will do, for maximum we will connect these resistances in series like this. Okay, means, and these values are given 20 ohm, 50 ohm and this is your 100 ohm. So in this case the value of equivalent resistance will be 20 plus 50 plus 100 means 170 ohm is your answer. Okay, and for minimum value, student, we will connect these resistances in parallel like this, in parallel. Okay, in parallel. Okay, now in this case, for getting equivalent resistance, we use this formula: 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is your 20 ohm, this is 50 ohm, this is 100 ohm. So this is now 1 by 20 plus 1 by 50 plus 1 by 100. This is now 100. This is 5 plus 2 plus 1. This is 8 by 100. This is 2 by 25. And so since 1 by R equals to 2 by 25, so R equals to 25 by 2 means 12.5 ohm is your answer. Student, this was question number 26. And now we will solve question number 27. Question number 27. Student, this question is saying a bulb is made using two filaments. A switch selects whether the filaments are used individually or in parallel. Okay, when used with a 15 volt battery, the bulb can be operated at 5 watt, 10 watt or 15 watt. What should be the resistances of the filaments? Okay, student, the question is saying a bulb is made using two filaments, means the situation is like this. Suppose that this is one of the filament and this is another filament. Okay, and let resistances of these filaments are R1 and R2, and a bulb is made using these two filaments, means the bulb is like this. Student. Okay, now this is your bulb. Okay, you can see, and two filaments, a switch selects whether the filaments are used individually or in parallel. There is also, student, a switch like this. There are two switches, so that student, the two filaments can be used individually. When this switch will be closed, then this filament will be used, and when this switch will be closed, then this filament will be used. So these two filaments can be used individually or in parallel when these two switches will be in closed mode. Okay, let this inter is connected across any source. Okay, now the question is saying when used with a 15 volt battery. Okay, when used with a 50 volt battery, the bulb can be operated at 5 watt, 10 watt or 15 watt. Student, three conditions are given: 5 watt, 10 watt or 15 watt. Obviously there will be three conditions. One, when any one filament will be used. Second condition, when second filament will be used, and the third condition, when both filaments will be used in parallel condition. Okay, so and accordingly there are three values of power. Okay, student, from these values of power we can find out value of resistances. Three possible resistances. Obviously, one value of resistance when for any one filament, second value of resistance will be for another filament, and third value of resistance will be equivalent of the two resistance. Okay, I hope you will be understanding. Now 5 watt resistance, student, from this rated power, value of power, we can find out value of resistance according to this formula. We know we have P equals to V square by R. Okay, from here we can write R equals to P V square by P. Okay, now V is the potential difference across the bulb. So when the value of rated power is 5 watt, in this case the resistance will be, value of resistance will be 15 square V square divided by power. This is 5 watt. This is 225 by 5. This is 45 ohm. Okay, so when 10 watt will be used, concept should be clear. In any case the value of voltage will be always 15 volt, because in any case when this will be used single only this filament will be used and this will be open, so voltage across this will be 15 volt. When this will be used, this filament will be used. When this will be closed and this is open, then again if voltage across this will be 15 volt. And when these two are both in parallel, their equivalent, the voltage across the equivalent resistance of these two will be again 15 volt. So in any case we will use the value of V equals to 15 volt. Okay, again for 10 watt, in case of 10 watt the resistance, value of resistance will be 15 square V square divided by P, power is 10 watt. This is 225 by 10 equals to 20.5 ohm. Now when value of power is 15 watt, in this case R equals to 15 square divided by 15. This is 15 ohm. Student, now in fact we have to find what should be the resistances of the filaments, means we have to find the value of R1 and R2. Certainly these three, among the three value of resistances, 45 ohm, 22.5 ohm and 15 ohm, two values will be in case when the two filaments are used individually, and any one value will be when these two filaments are used in parallel. Okay, student, we also know that in case of parallel condition, when the resistances are connected in parallel, then the value of equivalent resistance is always less than the least individual value. And here the least value is 15 ohm. So it means certainly this 15 ohm is when the two filaments are used in parallel. It means the individual value of resistances will be 45 ohm and 22.5 ohm. And when these two will be connected in parallel, then their equivalent resistance will be 15 ohm. In fact, you can also check this value 15 ohm when these two will be in parallel. So equivalent, what will be the value of equivalent resistance? R1 R2 by R1 plus R2, 45 into 20.5 divided by 45 plus 22.5. When you will solve this, then you will get the same value, 15 ohm. So from here you can also prove that this is when the two filaments are used in parallel. Okay, so your final answer is 45 ohm and 22.5 ohm. Okay, student, so let us move towards question number 28. Student, this question number 28 is saying figure shows a part of a circuit. For 28 students, the figure is given in book. For question number 28, figure is given and the figure is this. There is a circuit like this. Circuit like this, and the value of resistances, all resistances has been given. These are 5 kilo ohm, this is 20 kilo ohm, this is 10 kilo ohm, this is 100 kilo ohm. Now these 2 points are A and B. Now this figure is given in question, student. Now the question is saying figure shows a part of a circuit if a current of 12 milliampere exists in the 5 kilo ohm resistor. this 12 milliampere current is flowing through this 5 kilo ohm resistance. Okay, then find the currents in the other 3 resistors. We have to find the value of current flowing through these 3 resistors, and also what is the potential difference, PD, for potential difference between points A and B, and we have to also find the value of potential difference between points A and B. Student, very easy. You can understand this 12 milliampere current will divide here at this point. Let the current flowing through this 20 kilo ohm is I, so the current through this will be 12 minus I. Okay student, now and again from Kirchhoff's current law you can understand again finally net I plus 12 minus I means finally 12 milliampere current will flow through this 100 kilo ohm. So no problem, from 100 kilo ohm 12 milliampere current will flow. Issue is to find the value of current through these 2 resistances. Very student, you can understand this, the potential difference between these 2 resistances, if point, this is point P, then this point will be also P. If this point is Q, then this point will also Q. Means these 2 resistances are across the same 2 points P and Q. Means this is mean to say that the potential difference between these 2 resistances are same. So here you can write potential difference across 20 kilo ohm. Potential difference across 20 kilo ohm equals to potential difference across 10 kilo ohm. Okay, now the potential difference across 20 kilo ohm, current I is flowing, so from Ohm's law V equals to IR. This is I into R is 20, and this is potential difference through this is IR. Current 12 minus I is flowing. 12 minus I, value of current flowing through this is 12 minus IR. Value of R is 10. Okay, now from here you can find out the value of I. 20 I equals to 120 minus 10 I. This is 30 I equals to 120, and so value of I is 4 milliampere. Means the current flowing through the 20 kilo ohm is 4 milliampere is your answer, and from this obviously 12 minus 4 means 8 milliampere. You can understand. Okay student, now we have to find also the value of potential difference between point A and B. Now very easy. Now potential difference between point A and B means VA minus VB. Simply move from here, start to move from point A and move towards point B. And write potential difference across each resistance. From across this resistance will be current is 12 milliampere, resistance is 5 kilo ohm. So V from V equals to I. Potential difference across this is IR, so 12 into 5 plus I 4 into 20 across this plus 12 into 100. So this is 60 plus 80 plus 1200. So this will be 1340 volt is your answer. 1340. This is your question number 28. We are solving question number 28. Now let us move towards question number 29. Student, this question is saying an ideal battery sends a current of 5 ampere in a resistor. Okay, we have a resistor, let its resistance is R, and a battery when connected across it, an ideal battery is connected across it, the current flowing through it is 5 ampere. This condition is given. Question is saying further, when another resistor of value 10 ohm is connected in parallel, when another resistor of value 10 ohm, okay, means now a resistance of value 10 ohm is connected in parallel, as you are saying. Okay, now the current through the battery is increased to 6 ampere. So in this case the current through the battery is now 6 ampere. Okay, find the resistance of the first resistor. We have to find the value of R. Simple. Okay, now let the battery, the EMF of battery is E, then from this condition, from first condition, we can write from Ohm's law V equals to IR, E equals to current flowing is 5 to 5 resistance is R. Let this is equation 1 now. And also student, you can simply replace, you can simplify this circuit you can simplify as like this, since these two resistances are in parallel, you can write a single resistance having value 10 R, R1 R2 by R1 plus R2, 10 plus R. Okay, and now the battery is connected like this and the current flowing through is 6 ampere. These two are same circuit, equivalent circuit. Now from here we can write from Ohm's law V equals to IR, E equals to current flowing is 6 into equivalent resistance. Resistance is 10 R divided by 10 plus R. Let this is equation 2. Now from equation 1 and 2 you can see E equals to 5R, E equals to this, means these two will be equal, means by 1 and 2 you can write 5R equals to 60R divided by 10 plus R, means 50R equals to 50R plus 5R square equals to 60R. From here we can write 5R square equals to 10R, so value of R is 2 ohm. You can see from here 29. So now it's an easy question. Now let us move towards question number 30, student. Question number 30. Question number 30. Student, find the equivalent resistance of the network shown in figure between points A and B. Okay, again figure is given for this question, student. Question number 30. The figure is like this. Figure is like this. You have three resistances having same value R, small r for each. Now these two resistances are short circuited, and again like this you have to give in these 2 points are, this point is A and this point is B. So student, we have to find the value of equivalent resistance between points A and B. Okay student, between points A and B we have to find. Student, for this question, for this type of questions, okay, what is our strategy? Just see here, if this point is A, then this point is also A. You can write A, so this point you can also write A. Okay, now similarly if this point is B, you can write B, and similarly you can again write this point as B. Now notice that this resistance is between points A and B. Similarly, this resistance is between points A and B, and similarly this resistance is also again between points A and B. Means in fact you can redraw this figure like this. The three resistances are like this. Student. And let this is point A and this is point B, and the three resistors are R. In fact, be very clear that these two circuits are equivalent, completely equivalent. There is no difference. Okay, and from here you can understand the equivalent resistance, since these three are connected in parallel. Now these three are connected, very clear. These three are connected in parallel having same value, so equivalent resistance will be R by 3D. Very clear. Okay student, so let us move towards question number 31. So this question is saying a wire of resistance 15 ohm is bent to form a regular hexagon ABCDEFA. Okay, we have a wire having total resistance 15 ohm, and what we do, we bend this wire in form of a regular hexagon, like this. Okay, in form of a regular hexagon like this. Okay, obviously you can understand the resistance of each side of this regular hexagon. Resistance of each side of this regular hexagon will be same. Means to say if its value is R, smaller, its value is also R, smaller, 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 smaller. Why? You can understand, since we are making this hexagon with the same wire, means area of cross section for each, if you talk about any single side, any single section, then area of cross section for each section are same. Rho, R equals to rho into L by A, R equals to rho into L by A. Okay, area of cross section for each section is same. Length is same, regular hexagon length is also same, rho is same because of obviously same material, they all are. Okay, and so this total resistance 15 ohm will be equally divided, means in other words you can say the resistance of each section will be same, each section will be same, and so you can write the value of any single resistance small r equals to 15 by 6, since total resistance was 15 ohm, and this in turn you can write 5 by 2 ohm. Okay student, now the question is saying to form a regular hexagon, let give its name A, B, C, D, E, F, A, and so the regular hexagon is A, B, C, D, E, F, A. Okay, now the question is saying find the equivalent resistance of the loop between the points A and B, A and C, and A and B. Student, in three different cases we have to find the value of equivalent resistance. In three different cases, in first case we have to find equivalent resistance between A and B, A and B, A and B. Okay, now A and B, student, whenever you have to calculate equivalent resistance in such cases, then how do we think? Just listen. If when you have to find the value of A, equivalent resistance between A and B, then assume that a battery is connected between A and B like this, A and B like this, A and B, a battery is connected. Okay, since we have to find value of equivalent resistance between A and B, so we connect a battery between A and B. Now what will happen? The current flowing through this delivered through this battery will be distributed, divided here like this, like this. Okay, now this value of current will flow this, and this, and again from here total current I, if I was delivered, total current I will flow. I want to say that here in this situation these 5 resistances will be in series, because same current will flow through these 5 resistances. Okay, so equivalent resistance of 5 resistance will be 5R since they are connected in series, and again in turn that 5R resistance and R will be in parallel, because that 5R equivalent of this 5 is between A and B, and also this R is also between A and B, means 5R and R will be in parallel. So in this case equivalent resistance will be 5R into R, 5R into R divided by 5R plus R, this becomes 5R by 6, 5 by 6 into value of a small r is 5 by 2, 5 by 2, this becomes 25 by 12, this becomes almost 2.0 ohm is your answer, okay, when between A and B. Okay, let us see next part, between A and C. Okay, now between A and C, again now in this case we have to find the equivalent resistance between A and C. So now we will assume that a battery is connected. For second part I am drawing next figure. Assume that the battery is connected between A and C. Between A and C means the situation is like this. Now what will happen if I current is running through here, that this I will be divided here. Okay, now and see this current, this current will move like this. Okay, and this part will move like this, and again here these two will meet, and finally again same current I will come here, I, like this. Means here I want to say that in this case this and these 4 resistances will be in series, because same current will flow through these 4 resistances. So equivalent of these 4 will be 4R, and similarly these 2 resistances will be in series, because same current R is flowing through these two resistances, and their equivalent will become R plus R, 2R, and now in turn that 2R and 4R, these two are will be in parallel. Why? Because this 4R resistance will be connected across A and C, and similarly this 2R, equivalent of these two, is also connected between A and C. So this 4R and 2R will be in parallel. So simply now find equivalent of 4R and 2R when they are connected in parallel. Okay, so in this case equivalent resistance will be 4R into 2R divided by 4R plus 2R. This is 8R divided by 6. This is 8 by 6 into value of R is 5 by 2. This is 4 2 10 by 3. This is 3.33 ampere. Okay student, now next part number C. Here we have to find equivalent resistance between A and D. Now A and D, between A and D, in this case again what we will assume? We will assume that a battery is connected between A and D, like this. Again, now you can understand in this situation what will happen. Current divided here, this move through there like this till here, and now again current through this side will move like this. Means equivalent of these three will be in series because same current will flow through these three resistances, and so their equivalent will be 3R. Similarly, these three resistances in this case will be in series because same current will flow through these three resistances, so their equivalent again is 3R. So 3R and 3R, you can understand now, these two will again in turn will be parallel because both will be connected across A and D. So in this case equivalent resistance will be 3R into 3R divided by 3R plus 3R, and so this is 9R by 6. This is 2R by 3R by 2. This is 3R by 2. This is 3 by 2, and the value of R is 5 by 2. This is 15 by 4. This is 3.75 ohm is your answer. Okay student, so we were solving question number 31 student, 31, and now let us solve question number 32. Question number 32 student. Question number 32 student, this question is saying consider the circuit shown. Question number 32. Consider the circuit shown. In fact student, again for question number 32 figure is given in question and the circuit is like this. This is a switch. The value of these two resistances has been given. This is 10 ohm. This is 20 ohm. This is your 3 volt. Now, okay. Question is written here. You can see. Consider the circuit shown. Okay, now this is the circuit. Find current through 10 ohm resistor. We have to find the current flowing through this 10 ohm resistor when switch S is A, open, B closed. In two condition, when in first condition when switch is open, when S is open. Okay student, when S is open, as you are seeing in this figure, what will happen? The current flowing through this, let this current is I, this current is I. Obviously total current will flow through this, and no current will flow through this because the circuit is open. So current will not flow through this section, and so total current will flow through this section. And in this case simply we have this circuit. These two will be in series, so equivalent resistance will be 10 ohm plus 20 ohm, 30 ohm, and the battery is connected across this is 3 volt I. Okay, so the value of I in this case, what current will flow through this 30 ohm, same value of current will flow through this 10 ohm, and same value of current will flow through this 20 ohm resistance. Concepts will be clear. Okay, now so the value of current is I equals to V by R from Ohm's law, 3 by 30, this is 1 by 10, this is 0.1 ampere is your final answer. Okay student, now B part, when S is closed, when switch S is closed, when switch S is closed. Okay, now student, in this condition when switch S will be closed, what will happen? Total current flowing through this. Now from after this point, total current will flow through this, because now this is now short circuited, so current will not flow through this. Means the situation is like this, now the switch is closed, this is closed, switch is closed now, this is 10 ohm, this is 20 ohm, and this is now your battery. Let current flowing through in this condition is I dash. If the current flowing through flowing is I dash in this condition, then what will happen? This I dash current will flow through this, and now this, like this. Current will not flow through this 20 ohm resistance. Okay, now so in this case simply you can now redraw this figure, this 10 ohm resistance and the battery connected across it. Its value is given 3 volt, and so now value of I dash will be V by R from Ohm's law, 3 by 10 means 0.3 ohm. Sorry, 0.3 ampere is your final answer. Okay student, I hope you should have no any confusion. Let us meet in next class with solution of next questions. Thank you.